All right, so we are recording. So I'm just going to switch screens so that everybody can see what I am presenting. Just give me 1 second. And okay, can you guys see the screen now?
Yep, we can see Python classes.
All right, excellent. So I'm going to just go ahead. There's only about 10 slides that are just going to give a bit of a background on what we're going to be doing during the live coding session. If anybody has any questions, please feel free to stop me. Otherwise, you can put them in the chat. Because I'm not going to be looking at the chat, maybe Sandeep could ask or butt in or yell at me if somebody's putting messages in the chat.
Sure, we'll do that.
You might want to get closer to your microphone. You got a little far away all of a sudden.
It's probably because I got closer to the air conditioner. Is that better?
Yeah,
that's a little
better.
Well, how about that? A little bit better, maybe.
Yeah, we can hear you fine right now.
Okay. So I'm going to go over just some basics of Python classes. So this is an outline of what we're going to be talking about. So the first thing is what is a class? And then what do classes do? How can we use classes? And then we're going to get into some live coding. If you've used classes before, you might not get into all of the functionality that you've covered on your own. And you can potentially do that in a follow-up session to this if there's interest. But for today, we're just going to be covering some basic class functionality. So to start off, basically when I, like everybody else, started to learn Python, we were all introduced to different data types like strings, lists, integers, floats. And when you create a new list, for example, that object has built-in methods like the sort method, the append method, and the insert method. And those built-in methods are different depending on which type of data type you use. Like if you have a string or an integer, the built-in methods are going to vary.
I'm sorry, Aaron, could you maybe try again to get closer to the microphone, please? Just having a bit difficulty hearing you.
Just 1 second. Is that better? Can you hear me better now?
Yes, yeah, thank you.
Okay, no worries. So the thing is, what you're really doing when you make a new list, for example, is creating an object of the built-in list class in Python. So the same thing happens when you make, for example, a new pandas data frame. So here you're creating an object of the data frame class, or a new integer, you're creating an object of the integer class, or any other object in Python. So in reality, you've all been using object-oriented programming all along without actually realizing it. And this is something that when I first realized, it took me a while. It kind of blew my mind because I was kind of struggling to figure out why anybody would want to use object-oriented programming. And then I realized that that's actually how Python is built. Like all of the different data types in Python are objects. And they all have built-in methods. And you can make your own objects that do their own things, like lists or integers or characters or any other object that exists. And you basically started, and you just kind of need to continue. So why, other than that, would you want to learn object-oriented programming? So there are 4 main reasons. One is that your code gets broken down into self-contained modules, which makes troubleshooting easier. So if, for example, you have a car object and it's in a bunch of code where your car interacts with other cars and maybe a road and a bridge, and the car isn't working properly, you know which part of your code isn't working properly. You don't have to hunt through your whole code base. You just have to look at the car class itself.
Mhm.
So it allows you to troubleshoot your code much easier. You can also reuse your code through something called inheritance. And that basically means that classes can inherit methods from other classes. And we're going to see that tonight in the code that we're going to be writing. So you can have a parent class that has properties, and then you can have a child class that will inherit the properties of that parent class. So you don't have to rewrite all of that code that went into that parent class.
Mhm.
You can just reuse that code through inheritance. Your code also becomes more flexible because of a property called polymorphism. This isn't something that I'm going to get into tonight because it's a bit more advanced, but if we're going to have another lesson on Python classes, this is something that I would want to cover. And then the 4th reason would be that you can really solve a large problem by breaking it down into several different parts, like classes, that can then interact with each other, like the road and the car and the bridge, as opposed to having to sort of think the whole thing through from top to bottom in order to solve it. You can kind of break away chunks one at a time. So this is what the class looks like. This here is the name of the class. This class is just called car. This is a class variable, so it just exists inside the class, and then it gets used within this class method. A class method is basically like a function, except it just exists inside a class. So it's called a method instead of a function, because it only belongs to a class. And then there's a whole bunch of parameters here that you pass into the method like you would into a function, except in a class, the first parameter is always self. And then there's a double underscore init double underscore method that defines attributes that each class instance will have. So when you have this init method here, it basically is like constructor for every car type object that you're going to make. So if I want to make a car, I can call it whatever I want. In this case, I called it my car, which is kind of a boring name, but this is how you basically create an object that is a car. You ignore the self, and then you first call make, or you insert make, and then model, and then year, and then passengers. And so at this point, my car has the following attributes. The make is Honda, the model is Fit, the year is 2015, the number of passengers is 5, and in this case, the ID is 1. And I'll get into this a bit more when we're doing the live coding. This is because there's a class variable here where the ID is 1. And this line of code here assigns the ID of 1 to this particular instance of car, and then it auto increments it for the next time. So the next time you create a car, whatever it's called, its ID is going to be 2. So 2 other things that we should know before we get going is magic methods or dunder methods. Dunder is short for double underscore. So they start and end with 2 underscores, like the init method. What's so special about them? Why would you call it a magic method? Basically, you don't call it directly. Like when the call to make a new car object was made on the previous slide. So if we go back, we made a new car without calling init directly. We just said car.
So Erin, that means init will always be the very first function, but you won't need to call them that function anytime you need to create a new variable from your class, if you will.
So this is the default class constructor. So if you want to make a new, like construct a new object, like a new car, or you want to make your own class, by default, usually the first method that you want to make is the init method, so that you can make an object of this class. So that's the first one that you want to have there, because otherwise it's you can't really make new cars.
Okay. And ID equals 1, is that necessary that we need to assign ID equals anything for the very first time? or
No,
that's
so
okay.
this is if you want to say you're making a list of employees
Mhm.
and you want to keep track of employee IDs, and every time you make a new employee object, you want the employee ID to increase by 1. So
Okay.
that each employee ID is unique. It's different from every other employee ID. This would be a case where you would want to have a class variable like this,
Mhm.
and you would want to sort of auto increment it here every time you create a new object. Here, where I'm just making a car, it's not really necessary. I just put it here as an example of how you would do something like this, but you don't need to. It's just if you want to do that, that is how you would do it.
Got it.
And then the second thing I mentioned is that classes can inherit from each other. So, for example, you have a car class with some base features like we have make, model, year, passengers. But then maybe you want to have a race car class that's like a special type of car. So it would inherit everything from the car class. So you still have make, model, year, passengers, but then you can add extra things like max speed or 0 to 60 or like any kind of stat you can think of that you would want to include for a race car. You can make that an attribute of race car, but you can still keep the car functionality. But you don't have to rewrite the car code. And I'll show you how to do that in just a minute when we get to the live programming part. So we're gonna, like I said, take a closer look at magic methods and class inheritance during the live coding portion. And so does anybody have any questions to start off with?
No questions, Aaron. Just one clarification. When
Mhm.
I was doing the classes piece on the Python course on Code Academy, there was a word called instantiation. And
Yes.
is it the same thing as inheritance, or is it different?
No, so instantiation would be like here your what you're doing is instantiation. You're making an object of class car
Mhm.
called my car, and
And
that's what instantiation is.
okay, okay, just creating a new object from your class. That's it.
Yeah.
Okay.
So I'm going to go to a new share now, and can you now see my Visual Studio Code window?
Yep, we can see it.
Okay. So this is the class car that we were looking at earlier during the slides. And basically, the only thing it has extra is I added this line that says print self.id. And if I run this now, you can see that what comes out here is 1. So it's telling me that when this car, or my car, has been instantiated with the ID of 1. So for right now, I'm going to get rid of this because we're going to look at other ways that we might want to add behaviors to the car class so that it can do things that we want it to do. So what type of thing do you or might you want your class to do? One thing that you might want to do is have your class or have a method that will allow you to basically display all of this information. So you've instantiated your car, but if you try to print this out now, the only information you get is you've got a car object at this location in memory. So you're not really accessing any of this information. If you want to be able to retrieve this information and see what values are here, we're going to have to add some more functionality to the class. So to start off with, one of the first things we might want to do is add another dunder method that is called the __ repr method. I don't really know a better way of saying it, but this gives you a way to represent what values your object contains. So I'm going to say so basically, I've just said, or I've typed out a string here that allows me to, or that will insert the make, the model, the year, and the number of passengers that will fit in the car. So now if I run this, instead of just getting this main car object at the memory location, I get a Honda Fit that was made in 2015 that holds 5 passengers. So this particular method, you don't directly call it, but just by printing out your object itself, by putting this method into your class, it allows you to view the values that are in here. Now, what else do you think you might want to do with the car? Does anybody have any suggestions?
Honk.
Honk? Okay. So
This is all an abstraction anyway, right?
yep. But so here I'm going to make a honk method. So basically, I've just made a method that prints honk honk. So now if I if I type out my car dot honk below this and I run it again, it types out honk honk. It prints out honk honk. And even more, if you want to like if you want to add other properties that your car has, you can say like you can enter anything that is in here to like within the print string, and it will do that. Say you want to have the ability to change the model of your car. You can add a method that will do that. So the way you would do that is you just have to have a parameter self and then a new model for your car, and then you would now assign new model to your self.model. And then you can print out sorry. So say I want to change it to a Honda CRV instead of a Fit. So I'm going to execute this, and then it says the car's model is now CRV. So you can see how you would go about sort of building out functionality this way. You can use methods to just get specific like a method to get the model. So it would just return the model of the car. You can use a method to delete the model, a method to, for instance, change the year, or change the make. You can also make different cars. So, what other car do we want to make? Say,
Let's do Toyota Camry, something similar.
and then so now if I print this, or if I execute all of this, you can see that there's a Honda Fit that was made in 2015 that holds 5 passengers, and there was a Toyota Camry that was made in 2020 that holds 5 passengers.
So Erin, the Toyota Camry would have an ID of 2.
Yep. So we can also hold on.
So
Let's try this again. So
No, cool.
here you've got an ID of 1. Here you've got an ID of 2.
So anytime you need to add any new method, you use self always. You start with self as a parameter, if you will.
Yes.
Okay.
So
Can I just
say,
ask for a clarification about self? Because I guess this is the equivalent of the JavaScript mysterious this keyword. So I know you always put it in all the functions. What does it actually represent? That basically when you define this new instance, this is referring to this instant that you're creating right now?
yes. Yeah, so basically anytime you're executing a method on the like an instance of the object, like you're executing a method on the instance of the object, which is self. But I unfortunately do not have a lot of experience with JavaScript and object-oriented programming, so I don't know if this is exactly the same or not. But if that refers to the same concept, then I would assume so.
I guess so, just because I see that, for example, the init constructor or the init function in the beginning in JavaScript, you do the same. You would write this dot make equals make, this dot model equals model. So
yeah,
I guess it would be the same. It's just that I see also inside the functions that are inside the class, you also include them as a variable. So this is why I was curious.
yes, yeah. That makes sense.
Thanks.
So say now you want to have we want to use the example that we did, or that we were talking about in the slides, and we want to have a race car class. So way that you would go about making that class is you would set it up like this. And the fact that it's here in brackets means that it is a parent of the car class. So you can then go about making, if you want to make oops. I honestly don't know the name for any race car.
Just do a Honda, whatever. I don't think it matters.
So like
A Civic. Wow, I said Civic, and my iPhone thought I'm calling Siri. She's like,
so
Some race car. Oh, okay.
so now I'm gonna try. I've now made a race car that is basically, and I printed it out. So basically, the race car is a direct copy of the car class. It doesn't have any of its own functions at this, or methods at this point. It just is a direct copy. So you can see here that the Honda Civic was made in 2021. It holds 3 passengers and it has an ID of 3, because it copies everything, where it inherits everything directly from car. So sorry, go ahead.
One quick question. Let's say now in this race car, we need to add one more parameter, their max speed.
Yep.
Which is not part of the car. How do we go about that?
So you would then
again start with the init, because that has to be the very first function method.
So and then you would do help if I can spell. And then you would do so hold on 1 second. I am actually not sure if I got that syntax correct.
Super init one, right?
Yeah. Let's try it and see. Oops. So I will type 200 here, and I will then print that out. And it looks like I not get that right because I don't think that we need to do.
Okay, guys, I'm sorry, I have to go because laptop is dying. There's no electricity yet.
No worries.
So thanks a lot, and I'll watch the recording. Hopefully tomorrow if there's electricity.
Yes.
And, yeah.
Best of luck with your
Hope to
power.
see you next time. Yeah. Thanks.
Yeah. Bye. Oh, because I didn't put a dot there.
Oh,
Yay for syntax errors. Okay. So now it's giving me it's printing out this max
Max
speed
speed.
here,
okay.
and it's also doing the instantiation here, 3 passengers with an ID of 3. So say you then want to also have your you want to have your method, and you want it to do everything as the same as the car class, but you also want it to display the max speed. What you would do is you would have the you would define the repr method within the race car class, and then you would super and then all right, let's see if I got this right. I have invalid syntax.
As
What am I missing here?
maybe in, I don't know, maybe an equal sign.
Oh, where is my coding? There we go.
Oh, so
So-
anytime there's a race car and max speed is mentioned, that is when this line with a max speed of whatever speed is will get populated automatically. Otherwise,
Yeah, anytime that there is a max speed, or anytime that you have a race car and you want to print out, like you want to represent the race car, it's going to display the max speed as well as the make, the model, the year, and the number of passengers and the ID. So we've just added this functionality onto the repr method of the parent class. So now it's got this this max speed here. So basically, if you want a method to be exactly the same as the parent class, you can just invoke it the same way. So if I wanted to make a race car change model, I could just say next car dot change model, and that would work. But if you want to do added behaviors, you can build on top of methods that exist in the parent class by using the super clause here, and then adding the added behaviors below. So you have to add the parameter here in the method definition, and then you have the super method, which takes all of the parameters that the parent class has, and then the extra parameters you have to assign yourself in the same way that you would within any init method. So the cool thing about this repr method, for instance, is if you make say you make a list of cars and it has my car, other car, and next car in it, you can say for car in list of cars, print car. What do you think is going to happen now?
I think it is going to give us the different values of each car.
Exactly. So it's printing out that, so first there's the CRV that was made in 2015 that holds 5 passengers with an ID of 1, and a Camry that was made in 2020 that holds 5 passengers with an ID of 2, and then the race car, the Civic, that was made in 2021 that holds 3 passengers with an ID of 3 and a max speed of 200.
So when you did for car in list of cars, it actually gave us the value of the wrapper function, whatever the wrapper function is going to generate.
Yes.
Okay. Okay. So if you don't, let's say if in the race car class, we do not have the wrapper function, then we would only get the first 2 lines, ID1 and ID2.
No, so if you go like this, and you comment out the record function from the race car, it's still going to print out.
It's
these
just not
three
going to print out
things,
the additional piece.
but it's
that
not
we-
going to print out the speed.
I see. It's very interesting.
And then basically, you can make behaviors also that are just specific to, or I guess methods that are specific to the race car. So here, we just have a method called race. So if you type out next r.race and you execute, what's going on? Oh, I think it's just not liking back that it's below. Yeah, so it says I won the race. But then if you type out my car.race, it says the car object has no attribute race. So car does not, cars can't race, but race cars can race.
Okay.
Does that make sense?
Yeah, yeah.
Excellent. So I think for now, that is about all that I will cover, because it's been an hour. But I will make this code available so that anybody here and anybody that watches the video from now on can play around with it. And if you have any questions, for sure, let me know. If anybody is interested in learning more about classes, like learning how, or some more complicated behaviors, like how you can have a class that would inherit from multiple classes, or yeah, just things that are sort of a little bit more in depth, then I'm happy to do that as a later session as well.
Cool. Thanks, Erin. I think what I'm going to do is go back to Code Academy's classes exercise and just go through that again and see what I understood and how does that help me in getting better grasp of classes exercise there.
All right. Well,
Yeah.
hopefully
Great.
it was helpful.
Very helpful.
I'm going to stop my share and stop the recording.